Hello all, my name is Prashanth. I work as a principal member of technical staff at Salesforce, and I'm going to talk about how to use Kubernetes for machine learning. So let's get started with it. So this will be the agenda of our session. We'll be talking about the introduction, then we'll be talking about what is Kubernetes and why we need Kubernetes. We'll also touch upon the concepts of the machine learning lifecycle and the benefits of using Kubernetes for machine learning. And then we'll try to discuss some of the core concepts of Kubernetes, especially from a machine learning point of view. We'll try to understand some of the core platform tools that have been developed on Kubernetes, which are very specific to machine learning or deep learning. We'll be talking about Kubeflow to be very specific. Kubeflow is just not a framework, it's a platform combining multiple different tools together. We'll just look at a simple training example that we can use on Kubernetes with Kubeflow. Then we'll be talking about some of the best practices and real world use cases, and we'll be ending the session with future trends. It's going to be a little bigger session. I'm going to concentrate on a lot of theoretical concepts. Hopefully one day I'll get a chance to present my workshop with Conf42. And having said that, let's move on. As most of, I think by now, with all the chat GPTs, Claudes, and other LLMs out there, there is an AI revolution going on. And with this great AI revolution, there comes the need of great infrastructure too, and the optimal usage of infrastructure, saving the costs at the same time, saving the energy at the same time, and doing things more ethically. And we will talk about how we can do this with Kubernetes, how we can do all these things that I've been talking about with Kubernetes, and why Kubernetes is a pivotal concept or a pivotal framework or a pivotal platform for doing machine learning or deep learning. Just to revise a lot of bottlenecks that happen with machine learning and deep learning, the traditional infrastructures that a lot of these organizations have face a lot of issue when they need to scale up or scale down, especially in scenarios where there's a huge traffic that is coming to them. Now, how to handle this and all is what we're going to talk about in this session. Let's move on to the next slide. What is Kubernetes? I think most of you who are listening to this session might have already worked on Kubernetes, or you might be new to Kubernetes. But for someone who is really new to Kubernetes, Kubernetes is an open source container orchestration platform. That's a bigger word, but if any one of you have already worked with Docker, you already know about containers, but Kubernetes allows you to take the concept of the containers to next level by automating a lot of things. It introduces the concepts of deployments, rollbacks, services, stateful sets, daemon sets, and a lot of other things into it. But what does Kubernetes bring to the table by orchestrating these containers? The first thing is it simplifies the process of running your applications, right? You can simply run your application by packaging it as a Docker image and writing a couple of YAML files. It is also very reliable in the sense that when you deploy your application to Kubernetes, it takes care of it. It does the auto scaling. It does the horizontal auto scaling, the vertical auto scaling. It makes sure that it tries to keep your application as much as possible and scale it appropriately. It does container rollbacks, container restarts, container crash loop backs when a crash loop back is happening. What I mean by crash loop back is when your container is failing for some reason, it tries to bring back the containers. Some of the key features of Kubernetes, although I'm not trying to list all of them here, given the space constraints and everything else, yes, it supports automated deployments. There are several tools out there like Helm, Customize, several other things that allow you to package your deployment and allow you to do different kinds of automated deployments. It allows service discovery through its services. It has a built-in load balancer that it comes in the form of a service. As I spoke about, it has self-healing and fault tolerance. So it makes sure that it maintains the minimum number of replicas, and it also brings up the minimum number of containers required, minimum number of pods required. So pod is the basic unit of operation in Kubernetes. And finally, it takes care of resource management and scaling. Before we go and talk about why machine learning has to be done on Kubernetes, or what are the benefits of doing machine learning or deep learning, when I say deep learning, everything from neural networks to self-attention to transformers, why we should be doing that on Kubernetes, we'll just try to quickly understand at a very high level of how a machine learning lifecycle looks like. A machine learning lifecycle starts with data ingestion, right? You get the data from your customers or from whatever data sources you have. You try to clean that data or prepare the data for training, right? Preparing data is a multi-step process, but at a very high level, preparing data involves scaling your parameters, bringing them all to the same scale, converting the alphanumerics or alphabets into numerics, and so on, right? So that's what the data ingestion phase is all about. And then you do the training on the data, right? So you choose the appropriate training model to train your data. And there are several hundred algorithms which are available out there. Platforms like Hugging Face host a ton of models that you can use. Then you perform the model validation, right? You check for the performance, the accuracy, the confusion matrix, everything else, right? You check for how well your model is performing. And finally, you deploy your model into production. For deployment, also for model deployment, also they are available for deploying your models into production. And once you deploy your models into production, you spend time monitoring it, right? You try to monitor your model and then you repeat the process back again. You keep fine tuning your models every day with newer data, or you have a cron schedule, and according to the cron schedule, you keep refining your data. Now, let's talk about the problem, right? So what is the current problem? What is the problem if you don't use Kubernetes, or if you're trying to do machine learning on your own massive machine learning on your own first party clusters? Now, first thing is data volume, right? As more and more data, as you start receiving more and more data, obviously there's a lot of strain on your infrastructure. You have to store this data somewhere, you have to transform this data somewhere. Now, you can always provision the entire infrastructure at once, keep the infrastructure empty, and just do it based on the kind of the volume of data you receive. You can also end up having a very small infrastructure and you end up receiving large volumes of data, right? And how does Kubernetes solve it? Let's talk about it in the upcoming slides. And the computational intensity, right? A lot of deep learning models or neural networks today require a GPU. Having said that, would you really buy all the GPU ahead and keep it on your first party data centers or anywhere, right? Or anywhere on the cloud in the form of EC2 machines? So that's lots of cost to your company, right? So how do you handle this computational intensity, the lows and highs? During the peak periods, you might require a lot of GPU, a lot of CPU, but during the non-peak periods, you don't require a lot of GPU, a lot of CPU, you want to save your cost. There's also deployment complexity, right? So when you deploy a machine learning model, you need to have an inference endpoint. You need to have a proper inferencing backend where you deploy a model. So again, during peak periods, how do you handle it? Everything has to be scaled very efficiently. And finally, the cost involved in all these kinds of resource management that we have been talking about, right? So we have to efficiently allocate resources to all these workloads, which is very important, so that you can maximize the performance and you can reduce the cost at the same time. Now, this is a general problem with any scaling machine learning workloads. I'm not saying that Kubernetes is going to solve all these problems for you, but Kubernetes allows you to make right decisions, and it provides you several avenues by which you can easily solve all these problems. And then, now a question about why I should use Kubernetes for machine learning. The first thing is scalability, right? As I was speaking about, you can dynamically scale up and scale down. I have a couple of other slides which talk about the benefits, but at a very high level, the scalability, resource management, portability, and automation are the four biggest things, according to me, which Kubernetes provides you. Now let's dive deep into each one of this, right? So first is scalability, right? As I said, during the peak periods, you might want to scale. You might want to auto scale vertically, you might want to auto scale horizontally, or you might need to introduce GPUs, right? Now with Kubernetes, right, you can have, for example, if you're using the EKS cluster or something on Google Cloud or something on Azure, you already have this cluster at your disposal and you already have this nodes at your disposal, but depending upon your cost model, you will be charged only if you use them. So during your peak periods, you can use the GPU. Kubernetes makes it very easy through its YAML file and a couple of annotations. It easily allows you to target by using taints and tolerations on Kubernetes. It allows you to target the right nodes that have the GPU. It allows you to perform auto scaling. It allows you to perform horizontal scaling. You can set several parameters, several attributes based on which you want to perform the horizontal scaling. In fact, there are third-party CNCF platforms or tools like K8s. K8s is Kubernetes event-driven auto-scaling. So it allows you to auto-scale based on different kinds of factors. Okay, now from a resource management perspective, how does Kubernetes help you? If your organization, if your company is already using Kubernetes, you might have a bunch of microservices running on your Kubernetes already, then you're an apt company for running machine learning workloads on your Kubernetes. Kubernetes has the concept of resource quotas that allow you to restrict the amount of resources you can use. When I say resources, you can use per namespace. If you're a very large organization, you can segregate the groups inside into your sub-organizations or groups inside the organizations into namespace. For example, your finance and sales could use different namespaces, and they can keep submitting the machine learning workloads to their own namespaces without encroaching the others resource quotas or others resources, right? For example, finance will not go and use the sales resource, then sales will not go and use the finance resources. As I said earlier, you also have node selectors, taints, and tolerations that enable you to target specific nodes where you can perform machine learning or deep learning, and when you require GPUs, right? That's how Kubernetes helps you from the resource management perspective. From a portability perspective, so Kubernetes, you write whatever Kubernetes functionality you're going to write in terms of YAML files. If you're going to define your own custom resource definitions, you're going to use Go files. Now, these are pretty much independent of the cloud or wherever you're going to deploy them. Let it be on-premise, cloud, or hybrid, you'll still be working with the same set of YAML files, the same set of custom resource definitions, which themselves are YAML files and a combination of Go files. So there's a huge portability even if you shift your cloud provider or if you want to move to your on-premise Kubernetes cluster, there's a huge portability when you work with Kubernetes. Okay, so we have discussed some of the basics of Kubernetes, but let's try to understand some of the core concepts of Kubernetes. And these are very core. Some of you might already know this. From a machine learning perspective, there are 4 things that we need to know about Kubernetes. Having said that, this is not the entire list. I'm just trying to put the 4 important lists. There are several other built-in resources that Kubernetes provides, and there are several hundred projects in Cloud Native Compute Foundation, CNCF, that will work around the Kubernetes ecosystem. For example, the Orgo rollouts, which allows you to roll out which makes the rollout deployment rollouts very easy or rollbacks very easy. There are hundreds of CNCF providers out there who built a lot of resources around machine learning and Kubernetes. But for our session today, we'll discuss the 4 most important things: the pods, deployments, services, and namespaces. Pod is the smallest deployable unit in Kubernetes, and deployments are the ones that bundle all your pods together. They allow the pods they decide the number of replicas a pod can have. They allow the auto-scaling, horizontal auto-scaling, and vertical scaling. The services are the ones that expose your deployments to the outside world. And obviously, we spoke about namespace earlier. They allow you to logically group your resources, which just by improving the isolation and as well as the security. And it also allows the proper resource management of your Kubernetes cluster. So 4 things: pods, deployment, services, and namespaces are the basic things, at least what you want to know when you're working with Kubernetes and machine learning. As I spoke about pods, deployments, and services, these 3 comprise the 3 main things that Kubernetes, these are the fundamental things that anyone should know when working with Kubernetes. And of course, with the machine learning workloads that we're going to discuss about. Now, there's one more thing which is really important, right? Kubernetes has this concept of persistent volumes and persistent volume classes and storage classes. So these allow you to store persistent data when you're trying to interact with the Kubernetes clusters. For example, if you have submitted a machine learning job to your Kubernetes cluster and you want to do some kind of checkpointing at some time, right? You want to store your intermediary model or intermediary parameters. That's where the persistent volume claims, and storage classes shine. And they are so easy to use that it's like any other source in Kubernetes. It's nothing but a YAML file. And of course, there is a vendor tie-up, right? But that is handled by annotations. And same goes with the storage classes, right? These are the concepts that allow you to store your data when machine learning workload is running, when you want to checkpoint, when you want to store your parameters, when you're actually running your machine learning model. So all these 3 help you to maintain some kind of persistent state when your machine learning workload is running. In fact, these 3 are not very related to machine learning workload. They're also related to any kind of workload that you're trying to run on Kubernetes. Okay. We spoke a lot about this. We try to understand what are the basics of Kubernetes. We try to understand what are the basics of machine learning and why we should be using Kubernetes for machine learning. Now, you can go in and build your own framework on Kubernetes and you can run your machine learning workloads over there. But there are several proven tools out there that allow you to run your machine learning workloads on Kubernetes. They just don't allow you to run, they also allow you to visualize, do an auto ML and several other things very easily. And now one of those very, very famous tools that is gaining traction these days is Kubeflow. It has been there for a while, but it's gaining a lot of traction with the new LLMs and foundation models is Kubeflow. So Kubeflow is an open source machine learning toolkit which simplifies the deployment and management of machine learning workloads. So it is specifically targeted for Kubernetes. It has several key features. Kubeflow, and we'll be talking about each one of them in the upcoming slide. It has several key features. It has training operators, built-in training operators. It has its own built-in serving infrastructure called as K8s. It has a Python library that allows you to write pipelines. And it also has a model storage. It also allows you to store the models and several other benefits, right? There's several key features that we'll be talking about in the upcoming slides. As I said, instead of building your own framework, it is an open source initiative that came up from a lot of successful projects, and Kubeflow makes it very easy to build, deploy, and manage your machine learning models. And it accelerates the AI development lifecycle. Kubeflow is a game-changing platform for machine learning on Kubernetes. Okay, now we'll try to talk about each one of the components on Kubeflow. Unfortunately, I couldn't put a lot of examples here in the slides, but definitely, as I said, we'll have workshops in the future. But what are the different kinds of Kubeflow components? The first component of Kubeflow is training operator, right? There's a built-in training operator in Kubeflow. There are several built-in. You can run a TensorFlow job, you can run a PyTorch job, you can run a Vexted job. So these training operators allow you to specify your training in the form of a YAML file. Now, it's a YAML file that could run across any cloud on premise as long as it has a Kubernetes cluster to run on. You can just interact with this training operator. Since it's a YAML file that Kubernetes understands, you can interact it with using by your kubectl file. Training operators is one of those things which easily makes running your training. You just need to follow a specific contract and create an image out of it and create the YAML file out of the image. The second important component is the Kubeflow serving. So once you have built your model and you've trained your model and you've validated your model, you want to deploy your model somewhere. And that's where the Kubeflow serving comes into picture. It has a standard Python API. It also has the YAML files that you can use to expose your Kubeflow serving. And there's also something called as a model mesh that provides high performance scalable model serving with intelligent routing, right? So it's beneath the K8s serving, but on the top you have Kubeflow serving, which enables you to serve your models very efficiently. So Kubeflow pipelines, right? So this is the third most important model. And in the Kubeflow pipeline, there's nothing but it's a Python framework that allows you to define your machine learning workflow, orchestrate it. So obviously it allows you to define your entire machine learning lifecycle in the form of a Python script. Having said that, it also has a YAML file. You can do it to a YAML file also. And it allows you to track the performance also. When we say track, you can also actually do an AutoML by using something called as Katib in Kubeflow. But we'll talk about Katib a little later. But this Kubeflow pipeline is a third component which plays a pivotal role in writing your entire pipelines, end-to-end pipeline in Python. And then you can deploy the Python pipeline and run the Kubeflow. Okay, so what does the life cycle of a machine learning workload look on Kubeflow? We define a Kubeflow job. In this case, I took an example of a TensorFlow job. And you can define it by using a Python script or a YAML file. We submit the job to the Kubernetes cluster. We monitor the progress by using the Kubeflow UI, and we finally deploy the model by using the Kubeflow serving. And we deploy the model, and of course, once you've deployed the model, you can actually use the model for inferencing by using the Kubeflow serving. So these are the data ingestion steps that we have already discussed. It involves working with data sources. Then you get all the data. I'm just trying to go through the step-by-step guide of how you want to do the machine learning on your Kubernetes. You start with data sources. You fetch the data from different data sources. You do different kinds of data transformation on it. You try to clean the data, remove the alphanumeric characters, alphabetic characters, scale everything to one level. And then you finally come out with a set of features, right? That's what is called as feature engineering, set of features for your machine learning model. Now, then you do the machine learning, then you do the actual training, you define the training job, you specify the resources that you want to use for the specific training job. Again, the training Kubeflow has its own training operator that you can use for performing the training. You specify the resources and finally you validate the model by using the Kubeflow pipeline components. And at the end, once you have the model ready, you try to serve the model by using the K8s serving. I just went into some of the internal details. You need to create an inference service resource to define your model serving deployment. You specify the model, especially where the model is located. And finally, you deploy the model by using the K8s serve. which provides you a REST endpoint. Now, this is the REST endpoint you can reach out to through your Kubernetes service, a gateway, which is associated with the cloud, with the cloud gateway, right? So you can reach from an external source to your serving endpoint on Kubernetes cluster. So what are the best practices for optimizing machine learning on Kubernetes? One thing is there's always you have to choose the right resources, right? And again, this is not something you can come up at one shot. You have to experiment and play around with it to choose the right kind of resources, right? And use the GPUs, right? Optimize the usage of GPUs, right? So having said that, don't make all your workloads run on GPUs. You can optimize the GPUs by using proper range tolerations or node selectors, and you can just run those workloads which really require the GPU, right? For example, the deep learning with million of parameters or billions of parameters. And finally, you need to keep monitoring the performance of your model. There are several ways you can monitor the performance, right? You can keep constructing the accuracy, you can keep constructing the confusion matrices, precisions, recalls, etc. To keep monitoring the performance of your application, and you keep training your model on a regular basis. Okay, so what are the different resource allocation strategies? I want to have a separate section for this, especially because we have to understand what are the right resource allocation strategies. Now, one of the basic things that you can do is you can have static resources, right? You can always hard code your resources. But there is a concept called as dynamic allocation that enables you to allocate your resources based on the workload. And finally, there is auto scaling, right? And you can do horizontal auto scaling or vertical auto scaling depending upon the number of factors, right? You can also use some of the resources from CNCF that enable you to do the auto scaling based on external factors like your queue sizes, your database sizes, some event that happens outside of your Kubernetes cluster. So there are three different ways basically we can do auto scaling: the static allocation, the dynamic allocation, and auto scaling. And we already discussed about this. Keep having your metrics, keep pumping your metrics, keep looking at your metrics, have proper alerts around your metrics. Collect and analyze your logs, right? Make sure that you collect and analyze your logs so that you can catch any potential problems. Have metrics for key performance indicators that keep monitoring the health of your ML applications. And if something degrades, immediately give an alert so that even before it starts degrading, you can have warning alerts, you can have critical alerts so that your teams can actually have a look at it and try to resolve the issue before it becomes a real production issue. What are the different security considerations? Till now we have spoken about the other kind of things apart from security, right? So we have covered every other aspect except the security. Now, again, since you're using Kubernetes has a very great security mechanism. It has built-in authorization in the form of RBACs, ABACs, and you can use authentication, right? You can securely access to your Kubernetes by using certificates. And of course, you can encrypt the data. So all these are really built into Kubernetes. I'm not going into the fundamentals of Kubernetes, but Kubernetes has several tools like Cert Manager. You can use service meshes like STO, Linkerd, or different other kinds of service meshes that enable you to achieve this different authentication, authorization, encryption because you're working on Kubernetes. All that is taken care for you. So two real world use cases that I really want to talk about, right? I'm not going to name any company over here, but I think finance services and healthcare AI are really gaining a lot from using Kubernetes for their machine learning. So financial institutions really use Kubernetes to deploy and scale the fraud detection models. Similarly, the healthcare providers use Kubernetes to deploy and scale medical image analysis models, right? So Kubernetes is gaining a lot of traction across these industries as the foundation for scalable and reliable machine learning deployments, right? So these are a couple of real world examples where, in fact, we do a lot of these things. We build a platform and we do a lot of these things for the other platforms that are there within our own organizations. As I said about, there are financial services, right? A lot. In these days, I think any financial organization or a health organization should have a Kubernetes cluster, and maybe having a Kubernetes cluster, or they might be moving towards an idea of a Kubernetes cluster to deploy their own microservices. And since if they already have a Kubernetes cluster, they can use the same Kubernetes cluster for their machine learning workloads. And it really helps in a lot of things, right? For fraud detection, for risk management, for customer analytics. So all this is where Kubernetes and machine learning workloads together can help in the financial services. As we spoke about in healthcare, there's medical imaging, drug discovery, personalized medicine. Although all these are not directly related to Kubernetes, but Kubernetes allows you to make all this very easy, very streamlined, focusing on performance and minimizing the costs. Now, before I wrap up, there's some future trends that we're going to talk about, right? There is serverless ML on Kubernetes. There is something called as K8s that is coming up that is going to offer the serverless platform on Kubernetes. Function as a service, right, which is gaining a lot of traction. You can deploy individual ML functions directly, and event-driven architecture, and that's what I was talking about, Kubernetes event-driven architecture. KDA, you can go and look out for it on CNCF. So all these are really evolving. KDA is pretty much stabilized these days. All these are really evolving and providing a lot of benefits for someone who is trying to use Kubernetes for machine learning. And thank you so much. You can always write to me for any of your questions. I'm available at prashanth.16@gmail.com. Please do mail me if you have any questions. I'll try to reply back to you as soon as possible. And that's what it is, right? So we have discussed about Kubernetes and how it is the foundation, how it is becoming the foundation of scalable AI. What all it does is what we've discussed in this section. And I really want to thank everyone for listening to this session. And thank you, Conf42, for providing me an opportunity to talk in this session. Hopefully, I'll create a workshop in one of the future upcoming Conf42 sessions if possible. But again, thank you so much for listening to me.